I am Akhilesh and I am going to present a video on simplification of CFG. Just to give a brief about CFG, CFG stands for context-free grammar. It is a formal grammar which is used to generate all possible patterns of strings in a given formal language. Context-free grammar can be defined by four tuples as G equals V, T, P, S, where V stands for the set of variables or non-terminals, T for the set of terminals, P for the set of productions, and S for the start symbol. Simplification of context-free grammars involves the process of reducing the complexity of grammars by eliminating all the redundant and unnecessary production rules to make the grammar more concise and easier to work with. Methodology: CFG involves removal of the following productions. Removal of useless productions. These are the productions that are either unreachable or redundant. Removal of null productions. They are nothing but the productions where a non-terminal symbol derives an empty string. Removal of unit productions. These are the productions where a non-terminal symbol directly produces only another non-terminal symbol. In this video, I will be dealing only with the removal of null and unit productions. The process to remove the null productions is as follows. The first step is to find out all the non-terminals which have epsilon productions. After finding it out, for all the other productions, update them by removing all the nullable non-terminals found in the first step. Finally, remove all the epsilon productions from the final grammar obtained. To understand this better, let's solve an example. So this is the example. Here we find out that there are two productions, A gives epsilon and B gives epsilon. Our task is to remove these two productions without altering the set of strings they produce. Now consider the production S derives ABA. If we consider the first A at RHS as epsilon, then we get the production S gives BA. Similarly, if the last A at RHS is epsilon, then we get S gives AB. If only B is epsilon, then we get S gives AA. If both A and B are epsilon, then we get S gives A. And then if both A are replaced by epsilon, then we get S gives B. Finally, we get that S gives AB, BA, AA, A or B. To understand this concept better, let's solve an example. So this is the example and we find out that there are two productions, A gives epsilon and B gives epsilon. Our task is to remove these two productions without altering the set of strings they produce. Now consider the production S derives ABA. If we consider the first A at RHS as epsilon, then we get the production S gives BA. Similarly, if we consider the last A at RHS as epsilon, then we get S gives AB. If only B is epsilon, then we get S gives AA. If both A and B are epsilon, then we get S gives A. If both A are replaced by epsilon, then we get S gives B. Finally, we get that S gives AB, BA, AA, A or B. Now, let us consider the production A gives 0A. If we place epsilon at the RHS for A, then we get A gives 0, which gives A gives 0A or 0. Doing the same for the production B gives 1B, we get B gives 1B or 1. Therefore, the final grammar after removing the null productions is as follows. Moving on to the next example, we see that there are two null productions B gives epsilon and C gives epsilon. To remove these two null productions, let us consider the production A gives ABCD. Replacing C with epsilon on RHS, we get S gives ABD. Next, if B is epsilon, then we get S gives ACD. Now, if A is epsilon, then we get S gives BCD. Now, if both B and C equals epsilon, we get AD. And then doing similarly, we get S gives BD, S gives CD, and then S gives D if all A, B, C are replaced with epsilon. Now, if we take the second production and proceed in the same way, that is, replacing first C with epsilon and then B with epsilon, we get A gives B or A gives C. Similarly, doing so for all the productions, we get B gives BB or B, and then we get C gives CB or C. Therefore, our final result after removing all null productions is as follows. Moving further to the next step of simplification of CFG, that is, removal of unit productions. Method to remove unit productions is as follows. Firstly, identify all the unit productions. If the production is the form A gives B, add the production A gives X wherever B gives X occurs in the grammar. Next, delete that unit production and then repeat the previous steps until all the unit productions are removed. Let us understand this concept better by solving an example. So this is the example, and here we find out that there is a unit production S gives Z and Z, which in turn gives 0 1. Replacing Z with 0 1 in the first production, we get S gives 0x 1y and 0 1. Now we find out that there is another production y gives x and x gives 0s and 0 0. Replacing x in the third production, we get x gives 0s 0 0 and 1, which is our final answer. Moving on to the next example. Here we find out that C gives D is one of the unit production. So upon replacement of D, we get C gives DD. Doing the same thing for S gives C, we get S gives DD or EF, which is the final answer. To understand CFG in a much more practical way, let us try to see the stepwise execution of a CFG for a particular input on JFLAP software. Let us consider the grammar of the language of form WCWR. To verify the syntax, we test if the written productions follow the rules of a CFG as follows. We go to test and we try test for grammar type. As we can see, this is a context-free grammar. Now, to see if a particular string is accepted and to construct a parse tree, we use the feature brute force parser. Let us try to execute the grammar with the input which does not follow the grammar. For example, let's give the input as ABB. This is not of the form WCWR, so this should not accept. As expected, the string is rejected. Now, let's give an input for which it should be accepted. For example, let's give AA, BB, C, BB, AA as input. As we see, the string is accepted. Now, let's find out the stepwise execution for the given input. We see that it follows S gives ASA and then S gives ASA. Now, S gives BSP and then S gives BSP. Finally, S gives C. If we observe the yield of the tree, it matches with the input, that is AA, B, B, C, BB, AA. We can also see the same thing in the form of a table where we can observe how the string is recursively being produced. So this is the table. Now let us consider another input which is of the form WCWR. Let us give the input as ABB, AA, BB, C, BB, AA, BB, A. As expected, the string is accepted by the grammar. Now let's check the stepwise execution of this grammar. The first production S gives ASA and then S in turn derives BSB. Now S again derives BSB and then S derives ASB and then S derives ASA. Now S derives BSB and then S derives BSB again. Now S derives C finally. If we check the yield of this tree again, this follows the input A, B, B, A, A, B, B, C, B, B, A, A, B, B, A. Now let's check the derivation table of this tree. As we see, we can find out how the string is being recursively generated. That is, S is being replaced by BSB. Now again, S is again being replaced by BSB, and then ASA, and then so on to get the final grammar. Now, we can also convert this into Chomsky normal grammar as follows. We can test this grammar by giving the same input. AA, BB, C, BB, AA. As we see, the string is being accepted. So that means that this is the correct conversion of the given CFG. Thank you.